everyone, good morning. My name is Manya, and today we'll be doing the AMC-8 2025 problems and solutions. We'll be discussing key strategies and tips to improve your score in the AMC-8, and today there will be a question and answer session where you can ask some questions at the end, and I'll try my best to answer them. So let's get started. Problem number 1. The 8-pointed star shown in the figure below is a popular quilting pattern. What percent of the entire 4x4 grid is covered by the star? So we have this 4x4 grid right here. This is a 4x4 grid. And in a 4x4 grid, there has to be 16 squares. And if we count these, there's going to be 16 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's 16 squares. And we need to find the shaded part. So shaded over the total number of squares. And we already know that the total number of squares is 16. So all we need to do is just count the shaded parts and put that over the total. So I'm going to write blank over the total, which is 16. And here in the shaded region, we see that there's a 2x2 grid right in the center. And this 2x2 grid is covered completely by the shaded area. So that means that there's 4 squares in here that are covered. And we also see this block right here, so half a square plus half a square, which gives us one whole entire square. So this is 1 square, this is another square, 3 squares, and 4 squares. So we have to add another 4 to this shaded area. So this would be 4 plus 4, which would give us 8. So it'll be 8 over 16. And if we reduce that, then we would get 1 over 2. But we would need to convert this fraction into a percentage. And to do this, we would just need to multiply. We would just need to multiply by 100. So we'll be getting. So if we convert this fraction into a percentage, we'll be getting 50%. And that's how we got our answer choice B. Problem number 2. The table below shows the ancient Egyptian hieroglyphs that were used to represent different numbers. For example, the number 32 was represented by these hieroglyphs. What number is represented by the following combination of hieroglyphs? So they gave us a key right here, and all we need to do is just add them. Since in 32, they told us that this would be 10. So basically an upside down U, that would be 10. And 3 of them would be 30. And this also looks like 1, so that's easier for us. And those would be 2. So 30 plus 2 will be giving us 32. So all we would need to do is just add these numbers. So we have this one. Well, that one is the same thing as this one right there. So all we would have to do is just multiply this, or we already know that that's 1,000 since they told us a key. So 1,000 plus this one. This one is equal to 100, but there's 4 of them. So if there's 4 of them, then that would be equal to 400. 400 plus this one, and we already know that this is a 10, so this would be 2 of the 10s, which is equal to 20. And lastly, there's 3 of the 1s, which is equal to 3. And so we have this number right here, but all we would need to do is just add them. And if we add them, then we will get 10,423. And that would be our final answer choice B. Problem number 3. Buffalo Shuffle is a card game in which all cards are distributed evenly among all players at the start of the game. When Anika and 3 of her friends played Buffalo Shuffle, each player is dealt 15 cards. Suppose 2 more friends join the next game. How many cards will be dealt to each player? So we know that there's Anika and 3 of her friends, meaning that there's 4 players. If there's 4 players and each player is dealt 15 cards, then what's the total? The total will be 4 times 15, which is equal to 60. So there's a total of 60 cards. But suppose that two more friends join, meaning that there should be 6 friends now. Because the four friends are originally there, and now two more friends join. So 6 friends, and now how many cards will be dealt to each player? That would be 60 divided by 6, since we want each player to be dealt the same amount of cards. So that would be giving us 10, meaning that there should be 10 cards per player now. Problem number 4. 4. Lucius is counting backwards by sevens. His first three numbers are 100, 93, and 86. What is the 10th number? So he's counting backwards by sevens. And while he's counting backwards, his first three numbers are 100, 93, and 86. 100 is not the starting number. It is the first number when he starts by counting backwards. So what's the starting number? It would be 100 plus 7, which is 107. So his starting number would be 107. But now, since he's counting back by 7, we want his 10th number. And so his 10th number would be 70, because it would be 7 times 10. And so we would need to subtract 70 from the total. So we would do 107 minus 70, which will be giving us 37. And so his 10th number would be equal to 37. Our answer choice is B. Problem number 5. Matthew drives a truck to deliver packages in a neighborhood whose street map is shown below. Matthew starts at the factory labeled F and drives to location A, then B, then C, before returning to F. What is the shortest distance in blocks she can drive to complete the route? So Bethy starts at F, and then she goes to A, right? So it would be 1, 2, 3 to go to A from F. So 3. From A to B, she would take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10. To go from B to C, she'll take 1, 2, 3, 4, 5, 6. And from C to F, she will take 1, 2, 3, 4, 5. And now, if we add all of these numbers up, we'll be getting 6 plus 5, which is equal to 11, and 11 plus 3 plus 10, which is equal to 13. So 11 plus 13 will be giving us 24. And that would be our final answer choice C. Problem number 6. Sikoi writes the numbers 15, 16, 17, 18, and 19. After he erases one of his numbers, the sum of the remaining 4 numbers is a multiple of 4. Which number did he erase? First of all, we need to find the total of these numbers. So if we find the total, instead of adding up all of these numbers, we could just find the middle number and times it by the total number of numbers there are. And so it would be 17 times 5, which will be giving us 85. So if we add all these numbers together, we would still be getting 85. So 85 is our total, but now he erases one of these numbers and we end up with a multiple of 4. So that means that if we subtract, so we know that if it has to be a multiple of 4, it has to be an even number. But an odd number minus an even number will result in an odd number, such as 5 minus 2, which equals to 3. And so we would have to cross out all of our even answer choices, which is B and D. So it cannot be those two answer choices. Now we're left with A, C, and E. Suppose that it's A. So we would do 85 minus 15, which will be giving us 70. But 70 is not a multiple of 4, so that cannot work. How about we try maybe C? So 85 minus 17 is equal to 68, and 68 is a multiple of 4. 4 times 17. So C might be our answer choice, so question mark. And we can try 19. So 85 minus 19 is going to give us 66. But 66 is not a multiple of 4. So this cannot work either. And so our final answer choice would be C, 17. Problem number 7. On the most recent exam on professor's class, 5 students earned a score of at least 95%. 13 students earned a score of at least 90%, 27 students earned a score of at least 85%, and 50 students earned a score of at least 80%. How many students earned a score of at least 80% and less than 90%? So we know that 50 students earned a score of at least 80%. And we also know that 13 students earned a score of at least 90%. Well, how many students are in between those two percentage? So we would simply do 50 minus 13, which is equal to 37. And that would just be our final answer choice, D. Problem number 8. Isaiah cuts open a cardboard cube along some of its edges to form the flat shape shown on the right, which has an area of 18 square centimeters. What is the volume of the cube in cubic centimeters? So we know that this net right here, this is called a net of a cube. This one has a total area of 18 square centimeters. If it has a total area of 18 square centimeters, well then, we would have to find the area of one such square. And to do that, since we know that there's 6 squares here, we would do 18 divided by 6. And 18 divided by 6 would give us 3, meaning that the total area of one of these squares is 3. But what is the side length? Well, we know that if the side length is the square root of 3 times the square root of 3, that would just give us 3, since the square roots would cancel out. Because it'll be looking something like this, the square root of 3 squared. The square and the square root will cancel out, giving us just 3. So we know that the side length is equal to the square root of 3. Now, what they're asking us is that they're asking us to find the volume of the total cube in cubic centimeters. So to do that, we know that the volume of the cube will be base times height times length. So it will be base times height, which is length times width times height. And we know that in a cube, all of the sides are equal. So we would just do the square root of 3 cubed, which is the same thing as the square root of 3 times the square root of 3 times the square root of 3. And if we do that, we'll be getting 3 times the square root of 3, which is equal to 3 square root 3. And that would just be our final answer. And that's how we got our answer choice A. Problem number 9. Ningli looks at 6 pairs of numbers directly across from each other on a plot. She takes the average of each pair of numbers. What is the average of the resulting 6 numbers? So, on a regular clock, they're just asking us to add all of these numbers up, or not all of them, just the numbers that are across from each other, such as these numbers. And when we add them, they want us to find the average. So, we would do. So, first of all, let's just start off with 12 and 6. So 12 plus 6 is equal to 18. And now we can go to 1 and 7. 1 plus 7 is equal to 8. Now we can go to 2 and 8. That will be giving us 10. 3 and 9 will be giving us 12. We'll be giving us 12. We can go till 10 and 4, which will be giving us 14. And finally, we can go to 11 and 5, which will be giving us 16. So now we just have to add all of these numbers up, and we would have to divide by 6, since there's 6 numbers. And if we add them up, then we're going to be getting this 18 plus 12 will be giving us 30. And we have 14 plus 16, which will also be giving us 30. And we have 8 plus 10, which will be giving us 8. Or sorry, 18. So we have 18 plus 30 plus 30 divided by 6. And so the numerator would be equal to 78 divided by 6, which will be giving us 12. And so the average of all of these 6 numbers is going to be equal to 12. Answer choice E. Problem number 10. In the figure below, ABCD is a rectangle with sides of length AB equals 5 inches and AD is equal to 3 inches. Rectangle ABCD is rotating 90 degrees clockwise around the midpoint of side DC to give a second rectangle. So by the midpoint, I mean that this half is equal and this half is also equal, meaning that if AB is equal to 5, then DC will also be equal to 5, meaning that both of these sides are equal to 2.5 and 2.5. Okay? And now they're asking us, what is the total area in square inches covered by the two overlapping rectangles? What is the total area of all of this? But now the only problem is that we see this. We see this overlap. And so if we don't subtract one of the overlaps, then we'll be counting the overlap twice, which we cannot do. So we would have to add this up. So ADCB is equal to 3 times 5, which is equal to 15. And this rectangle is also equal to the gray rectangle, because they're just rotating 90 degrees. They're not any different. So 15 plus 15 will be giving us 30. Okay, but once again, we counted this overlap twice. So we would have to subtract it one time. And we know that this side length is equal to 2.5. And this is a square if you look closely, since they rotated 90 degrees here. So if this side length is equal to 2.5, then this side length will also be equal to 2.5. And we would just do 30 minus 2.5 squared, which is equal to 30 minus 6.25, because 2.5 times 2.5 is equal to 6.25. And 30 minus 6.25 is equal to 23.75. And that would be our final answer choice, D. Problem number 11. A tetromino consists of 4 squares connected along their edges. There are 5 possible tetromino shapes, I, O, L, T, and S, shown below, which can be rotated or flipped over. 3 tetraminos are used to completely cover a 3 by 4 rectangle, and at least one of the tiles is an S tile. What are the other 2 tiles? So we know that has to be an S tile. It has to. So in this case, we have these 5 tiles shown here, and we have an S tile. Okay, so if we have an S tile, then we can maybe place it something like this. Okay, so the S tile will be located over here. But then we have this whole entire shape, which we don't know which we need to do this. So we need to place 2 random shapes here to get a shape something like this. So to do that, we would just try to imagine, see, where there's one square here, or there's actually two here, and there's two going this way. So what shape could fit like that? Well, if we rotate L, it can fit over here. And we also see that there should also be a shape somewhere over here. So this shape would once again be L if we would rotate it or flip it over. And so this one should be L and this one should also be L, meaning that the other two shapes are L and L, which gives us answer choice C. Problem number 12. The region shown below consists of 24 squares, each with a side length of 1 centimeter. What is the area in square centimeters of the largest circle that can fit inside the region, possibly touching the boundaries? So here, I have a circle over here, or yeah, I have this shape over here, and we want it to be touching the boundaries here, or we just want it to be as big as possible. Let me draw a better circle here. Okay, so we have a shape something like this. Okay, and this is touching the boundaries here. This shape is touching the boundaries over here, or the majority of that. And this shape is pretty close to a circle. Okay? And see, if this shape is touching the boundaries, and we know that this is 2, and this is also 2. Oh, sorry. This we know that this one is 2, this one is 2, and this radius is also equal to 2, then now, see, see this part over here. This part goes more than 2, but it's way less than 2.5. This is 2.5 over here. But this one is also way less than 2.5. And the same thing as the other ones over here. This is way less than 2.5. This is way less than 2.5 too. So it can't be 2.5. And so it has to be just slightly, just very slightly more than 2. So suppose that the radius is equal to 2, then what would be the area? The area would just be pi times r, which is pi r squared, and the radius is 2, then it would be 4 pi. 4 times pi. So that's only if the radius is equal to 2. But now we know that the radius is just slightly more than 2. It's not exactly 2, but we know that it's more than 2, but it's less than 2.5. So it has to be just slightly more than, the area has to be slightly more than 4 pi. So in this case, 1 more than 4 pi would be equal to 5 pi. And once again, we know that it's more than 2 because of this area right here. It has to be the largest circle possible, but cannot be more than this grid. And so it has to be slightly more than 4, which would give us 5. Problem number 13. Each of the even numbers 2, 4, 6, and all the way until 50 is divided by 7. The remainders are recorded. Which histogram displays the number of times each remainder occurs? So we know that they're just giving us options for the histogram here. All of these. Well, we can see that 0 here, there's 0 here, there's 0 here, and there's 0 here, and there's 0 here as well. This one says that a 0 occurs 3 times. This one also says 3. This one also says 3, and this one says 4. This one also says 4. So we need to eliminate the answer choices, and to do this, we will need to find the even numbers which are divided by 7, which will result in a remainder of 0, such as 14. 14. Well, the first number would be 0, but 0 does not count here because it starts from 2. And then the next number would be 7, but 7 is an odd number. Then it would be 14, which would work. 21, no, 28 would. 35, no, 42 would work. And then 56 would work as well, but 56 is way more than 50, so there's only 3 numbers here. So since there's only three numbers, which if they're divided by 7 and are divisible and the remainder will equal 0. And so the answer choice cannot be D and it cannot be E either. Well, now if you look at the difference again, this one has 3 and this one has 4. This one has 4 as well. So they're saying that if they divide a number by 7, the remainder should be equal to 3. But there's only 3 numbers such as that. But this one is saying that there's 4 numbers, and this one's also saying that it's 4 numbers. So what we should do is that we should make, so the first number would be equal to 3, but 3 is an odd number, so that cannot work. How about 10? Okay, 10, 17, but 17 is an odd number, but we'll just write it for now. We can cancel it later. 17, 24, 31. There can also be 38. There could be 45. And yeah, so here we have the number 10, 24, and 38. And there's only 3 numbers like this. We do this. So since there's only 3 numbers, we must eliminate answer choice B, and we also must eliminate answer choice C, giving us answer choice A. Problem number 14. A number n is inserted into the list 2, 6, 7, 7, 28. And now the mean is twice as great as the median. What is n? So the mean just means the average, right? The mean is the average, and the median would just be the middle number. Middle number. What is n? First of all, we need to calculate the middle number. And to find the middle number, it's pretty easy since there's only 5 numbers. The middle number would be 7. Okay, so the median is 7, and now we need to calculate the mean, the average. Well, the average, if we would want to calculate, it would be 2 plus 6 plus 7 plus 7 plus 28 divided by 5, since there's 5 numbers. And if we would do this, then we'll be getting, there's 2 plus 20 will be equal to 30, and 6 plus 7 will be giving us 13, and 13 plus 20 plus 7 will be giving us 20. So it will be 15 by 5, which will be giving us 10. So our average right now is 10. But now they added a number and it's inserted to this list. And now the average is twice as great as a median, meaning that twice the median is 14, but the mean is 10. So if the median has to be equal to, if the mean has to be equal to 14, and now there's 6 numbers because they added a number n to this list. So 5 plus 1 is equal to 6, meaning that there's 6 numbers now. 14 plus 6 will be, 14 times 6 will be giving us 84. But now we have 84, and originally our total was 50. So we need to find out what n is, and to find out what n is, we would have to do 84 minus 50. And 84 minus 50 will be giving us 34, meaning that the number added to this list is 34. Problem number 15. K draws the 6 by 6 grid and he colors 13 of the unit squares silver and the remaining squares gold. K then folds the grid in half vertically, forming pairs of overlapping unit squares. Let lowercase m and uppercase m equal the least and greatest possible number of gold on gold pairs respectively. What is the value of lowercase m plus uppercase m? First of all, here, let me use this color. So he colors 13 of those squares silver and the remaining gold. How about we can do the greatest possibility of, how about we can do the least possibility of gold and gold? So we're trying to do the least. So if it would be least, then we would color this part 13. So that would be 12 here. So 12 here, and this would be an extra 1. So we have this right now, but the problem is that we also need gold. So here, let me change the color to gold. I'll just use this color and that. Okay. So we have 1 gold, 2 gold, 3 gold, 4 gold, and 5 gold. And now, if I fold this in half vertically, it'll look like the same thing, just mirror image though. So this part would be going over here, and this part, this gray area, would be going over here. So this would be the same thing. So there would be 5 gold on gold pairs. But now we'll make it the largest value now. For it to be the largest value, we know that it should be, so first let me start by using silver. To use silver, okay, so how about we can do 6 here. And now when they fold in half vertically, we already know that it'll be the same thing on the other side. But we want as many gold on gold pairs as possible. So how about we just do 6 silver on this side as well? Okay, so we have this. But now we would also have to add 1 here. And so it'll look the same thing on the other side, meaning that this one will also be going on this side. So now we need to calculate the gold on gold pairs. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 11. So we have 11 gold on gold pairs. Since this one is already taken over there, this one is over here again. Sorry, that's silver. If we fold it in half, this part will also be silver. So we have 11 here as well. And now they're asking what is the value of the smallest value of m plus the largest value of m as well. And if we add 5 plus 11, we add 5 plus 11, we'll be getting 16. And so our final answer would be equal to 16. Our answer choice C. So does anyone have any questions? Okay, so if no one has any questions, then we'll have a 2-minute break and we'll continue with problem number 16. everyone. Now break is over. We can get started with problem number 16. We just finished problem number 15 and everything before that. And we can start with problem number 16. So 5 distinct integers from 1 to 10 are chosen, and 5 distinct integers from 11 to 20 are chosen. No two numbers differ by exactly 10. What is the sum of the 10 chosen numbers? So we know that 5 numbers from 1 to 10 are chosen. So how about we take 1 plus 2 plus 3, 4 plus 5. Okay, and we also see that there's also 5 different numbers chosen from 11 to 20. But there's one condition. There's no two numbers that can differ by exactly 10. So in this case, they're also saying that here they cannot differ by exactly 10. So that means that has to be 16 plus 17 plus 18 plus 19 plus 20. And now we just need to add these all up. So once again, we can find the middle number here, and that will be equal to 18. 18 times 5, which will be giving us 90. And the same thing here. 3 times 5 will be giving us 15. And now we can just add these numbers up. 90 plus 15 will be giving us 105. And so that will be our final answer choice, C. Problem number 17. In the land of Mongolia, there are 3 cities, A, B, and C. There are 100 people who live in A, 120 who live in B, and 160 who live in C. Everyone works in one of these 3 cities, and a person may work in the same city where they live. In the figure below, an arrow pointing from one city to another is labeled with the fraction of people working in the first city who work in the second city. For example, 1/4 of the people who live in A work in B. How many people work in A? So our final answer, or our final question would be, how many people work in A? So we know that there's 100 people who work in A, who live in A, 120 who live in B, and 160 who live in C. So we will have to find 1/4 of 100, which will be giving us 25. So we will have to subtract 25 here because we know that 25 people who live in A go to work at B. And we would also need to find 1/5 of 100, which will be giving us 20. For B, we would have to find 1/3 of 120, which is equal to 40. Plus 40, and we would also need to find 1/6 of 120, which is equal to 20. So minus 20 here as well. So we don't really care about B and C, like how many people work in there for now. So I'm just like writing this like randomly, but A we do care. So I'll just write plus. This would be plus 40 here. Okay, so I'll just write plus here for now so that it'll be easier. And for C, we need to find 1/8 of 160, which will be giving us 20. So plus 20 as well, which will be 60 for A. And for C, we would also need to find 1/10 of that, which will be giving us 16. So we would also need to subtract 16 from here, and then add 16 over here. B and C are a bit messy, but A, we need to do this. So 100 minus 25 minus 20 is equal to minus 45. 100 is just there. So minus 20 plus So that will be equal to minus 45. And we would also need to add 60 to that, which will be just 15. Negative 45 plus 60 is equal to 15. So we would have to add 15 to our total, and our total is 100. So 15 plus 100 is equal to 115, meaning that 115 people work at City A. And we can go to problem number 18 now. The circle shown below has a on the left has a radius of 1 unit. The region between the circles and the inscribed square is shaded. If the circle shown on the right is 1/4 of the on the right, 1/4 of the region between the circle and the inscribed square shaded, the shaded region in the two circles have the same area. What is the radius r in units of the circle on the right? So here, suppose that we have a circle here. Okay, so we have a circle over. Okay, so we can have a circle over. Sorry, we can have a circle over here. Okay, so we have a circle over here, and suppose that the radius of this is equal to 1. But then we have another circle over here. Okay, it's a bigger circle over here, and suppose that the radius of this is equal to actually 2. Okay, so what is the area? What is the ratio of the sides? So the ratio of the sides would be 1 to 2. Okay, this makes sense, right? The radius. But what is the ratio of the area? Well, the ratio of the area, this one would be pi. This one would be pi r squared. So pi times r is square is just pi times 1, which is just pi. This one would be pi r squared as well, which is pi times 2 squared, which is pi times 4, which is 4 pi. So the ratio of the areas is 1 to 4, actually, right? Because it's 1 pi to 4 pi, which is 1 to 4. Suppose that we have maybe the same thing, except we have a larger circle. Suppose that this could be 2. Okay, so we can have another circle. This one can be 2. The radius is 2. Then this one will be equal to 4 pi. Okay, this one is equal to 4 pi. But now, suppose that we have a bigger circle. Okay, so we have a bigger circle now. And the radius of this is equal to 4. So if this one is equal to 4, then the area would be the total, which would be 16 pi. Because it's pi r squared, so 16 pi. 16 pi. Once again, the ratio of the areas is 1 to 4. 4 to 16 simplified is 1 to 4. So the ratio of the areas would be the same, even if it's a side length. Well, if you look on this picture over here in the actual problem, you see that the area of this shaded region, just this one part, just the blue part over here, to the ratio of this area and this pink part over here would be 1 to 4. Because four of these would make one of those. So if we only have one of them to the total area, it would be 1 to 4. So if the area is 1 to 4, then what is the side length? The side length will be 1 to 2 again, right? If you understood the circle over here, it would still be 1 to 2. No matter like what shape the area is, the side length will still be 1 to 2. And therefore the radius in units of the circle to the right, the radius over here is 2. Problem number 19. Two towns, A and B, are connected by a straight road 15 miles long. Traveling from town A to town B, the speed limit changes every 5 miles, from 25 to 40 to 20 miles per hour. mph. Two cars, one at town A and one at town B, start moving towards each other at the same time. They drive at exactly the speed limit in each portion of the road. How far from town A in miles will the two cars meet? So, first of all, we have two cars here. one that just starts right there and another one which starts right there. So now we need to find in which point do the two cars meet. They will most likely meet somewhere over here. But we can't just say somewhere over here, right? We need to be exactly specific since these answer choices are pretty close to each other. So now what we should do is that we need to find, so this is 25 miles per hour. As you travel 5 miles, how much time will it take? So 25 miles can be traveled in 60 minutes. We can travel 5 miles in X number of minutes. And how many? So we can just cross multiply. And when we cross multiply, we're going to get 60 times 5, which will be giving us 300. 325 times x, which will be 25x. So if we have 325x, we're going to be getting x equals 12. So since we got x equals 12, that means that this car will take 12 minutes to travel this much. How about this car? How long will it take to travel 5 miles in 20 miles per hour? So it will take 20 miles to 60 minutes equals 5 miles to x number of minutes. That'll be giving us 300. If we cross multiply again, 300 to 20x. And x is going to be equal to 15, meaning that car B, will be taking 15 minutes. But in the meantime, the car A won't just wait. So after it traveled 12 minutes, this one takes 15 minutes, the car just won't stop there. It'll just keep going. Because car A really wants to meet car B, right? The car A won't just stop there. They won't both just run at the same time towards each other. So car A won't wait over here. It'll keep going. So in this case, we need to find how many miles will it travel in 3 minutes? Since 15 minus 12 is equal to 3. So in 3 minutes, how many miles will it travel? So 3 minutes is 1 over 20 minutes. So 1 over 20 times 40, since it's 40 miles per hour, will be giving us 40 over 20, which will be equal to 2. So this car would have already traveled 2 miles. So let's write 2 over here. So after it traveled 2 miles, there's still 3 miles still remaining. So let's just write 3 over here. Still 3 miles remaining. And car B would have reached there. So if they both have the same distance, an equal distance to travel over here, they both go towards each other in the same speed, then they'll take an equal amount of time to meet each other. So since there's 3 miles here between both of them, they both travel at the same pace and they will both meet at the same time. So that means that they will both meet right in the middle at 1.5 miles. And we need to know how far is all of this from town A. So since this is 5 miles, 5 plus 2 miles over here, remember how car A won't wait for car B, it'll just keep going. 5 plus 2 plus 1.5. If you add them, that will be giving us 8.5, meaning that they met each other 8.5 miles away from town A. Answer choice D. Problem number 20. Sarika, Deb, and Rajab are sharing a large block of cheese. They take turns cutting half of what remains and eating it. First, Sarika eats half of the cheese, then Deb eats the remaining half, and Rajab eats half of what remains. Then back to Sarika, and so on. They stop when the cheese is too small to see. About what fraction of the original block of cheese did Sarika eat in total? So by a large block of cheese, we don't know what they mean. The cheese could be so big that Not we they can it's like so big. The cheese can be as big as they want. They don't like tell us how big it is. So we have to imagine that the cheese is so big that it'll keep going, keep going, keep going. By small as small as they can't see it, it can be like so tiny. They might have even a microscope to like cut it in half maybe. So we don't know what they mean by that. The cheese can be as big as they want, and by a small piece, they don't know what, or we don't know what they mean by that. So we just have to assume that it's as big as possible. So first of all, they have a large block of cheese here. And first, Sarika eats it first, and Sarika eats 1/2 of it. Then Dev eats 1/4 of it, and Rajiv eats 1/8 of it. And then Sarika eats 1/16. Dev eats 1/32. Rajiv eats 1/64. Sarika eats 1/128, and so on, right? And we don't know when they stop. So, in this case, we'll just have to use the infinity formula. And by that, I mean that, first of all, they start with Sarika eating 1/2. And 1/2 over the total, which is 1, right? 1 is total. So the total will be 1, which is the amount which they start with, 1 minus 1/8, since that is what the last part of the first one is, 1 of it. So Rajiv eats 1/8 of it. So we will have to do 1/2 divided by 1 minus 1/8. So 1/2 minus, or sorry, not minus, times 8, sorry, 1/2 times 8/7. Instead of doing 1/8 divided by 7/8, we can just do 1/2 times 8/7, which will be giving us 8/14. And if we simplify it, divide by 2, we will be getting 4/7, which means that Sarika would have eaten 4/7 of the cheese in total. Problem number 21. The Konigsberg School has assigned grades 1 through 7 to pods A through G, 1 grade per pod. Some of the pods are connected by walkways as shown in the figure below. The school noticed that each pair of connected pods have been assigned to different grade levels, differing by 2 or more grade levels. For example, grades 1 and 2 will not be connected in pods directly connected by a walkway. What is the sum of the grade levels assigned to pods C, E, and F? So, do you notice anything about these pods over here? Maybe 2 pods in specific? So, what I notice is that pod C and pod F over here, they're connected. So, they're connected to 5 other pods except for one of them. By that, I mean that C is not connected to G and F is not connected to D. Okay? So, suppose that C can be 1 and F can be 7. It doesn't really matter which way it can be. So F can be, they can like switch roles again maybe. Or it doesn't really matter where it is, okay? I'm just gonna do it like this, but it's up to you, like how you place them. So if C is 1, that means if C is 1, that means that G has to be equal to 2. Because C connects to every other pod except for G. So G has to be 2. So I'll just place this right on top here. Or actually, I'll just place it to the side. So now we see that F is 7. That means that D has to be 6. Because F is not connected to D. Only pod which is not connected. And now we're left with 3, 4, and 5. We see that A and B are directly connected to each other, but they have to be differing by 2 or more grade levels. So suppose that A is 3 and B is 5. Well, that means that here we see that A is directly connected to this part over here, A is directly connected to, or sorry, A, not A. G is directly connected to A, meaning that the 3 cannot go here because 2 is just, or 3 is just one more than 2. So we would have to place a 5 over here and the 3 down here. Since, once again, the grade level, the pods have to be defined by 2 or more grade levels. So it would be looking something like this, and E would have to be 4. There's no other option for E to be. So this is what we have so far, and this will work if we try every scenario. So suppose that we try C and B. These differ by 2, B and F differ by more than 2. So yeah, this would work. So they're asking us, what is the sum of the grade levels assigned to pod C, which is 1, plus E, which is 4, plus F, which is 7. So 1 plus 4 plus 7, which will be giving us 12. Therefore, our answer is A. Problem number 22. A classroom has a row of 35 coat hooks. Paulina likes coats to be equally spaced so that there's the same number of empty hooks before the first coat and after the last coat and between every coat to the next one. Suppose that there is at least one coat and at least one empty hook. How many different numbers of coats can satisfy Paulina's pattern? First, we need to make an equation. So we know that there's 35 hooks. 35 minus x. X is just like the total number of coats. 35 minus x divided by x plus 1. And we have to do x plus 1 because we need so if suppose that there can be here. So let me draw this right over here. So we have this, okay? Suppose that this is a straight line, okay? So this is a straight line and we have 1, 2, 3, 4, 5. We have 5 coat hooks. How many spaces will there be? 1, 2, 3, 4, 5, 6. So 6 spaces instead of 5. So if there's 6 spaces over here, then we have to add 1 to this. Because we have the first space, second, and so on to the very last space. That would also count. So this would be our final equation. But now we will have to substitute every value of x, which is possible. Suppose that, let me change the color. I'll use red. So suppose that x is equal to 1. If x is equal to 1, then we will have 35 minus 1, which is equal to 34. 34 divided by x plus 1, which is 2, which is equal to 17. And that is an integer. So that can work. How about x equals 2? X equals 2, we're going to be getting 33 over 33 by 3, which can also work. That is also an integer. How about we try x equals 3? If x equals 3, then we will be getting 32 by 4, which can also work since that is also an integer. Now, since I don't have space on the bottom, I'll be writing it right over here. We can do x equals 4. We'll be getting 31 over 5. But 31 over 5 is not an integer, so that cannot work. So let me cross that out. X equals 5, which will be giving us 30 over 6, which is an integer, which can work. X equals 6. That will be giving us 29 over 7, which cannot work. How about x equals 7? We will be getting 28 by 8, which cannot work either. That will not be an integer. How about we get, I'll write it over here, x equals 8. we will get 27 by 9, which is an integer, so that will work. X equals 9. We'll be getting 26 by 10, which is not an integer, and so that cannot work. X equals 10. Which will be equal to 25 by 11. So that will not work as well because that is not an integer. How about x is equal to 11? X equals to 11 is 24 by 12, which can work. So 24 by 12. And x equals 12 cannot work because it's 23 by 13, which cannot work. X equals 13 is 22 over 14, which cannot work either. X equals 14 is 21 over 15, which cannot work. X equals 15 is 20 over 16, which cannot work once again. X equals 16 is 19 over 17, which cannot work, and x is equal to 17 is 18 over 18, which can work. So we would get x equals 17 as well. Now they're asking us how many different number of codes can satisfy Paulina's pattern. So we have 1, 2, 3, 4, 5, 6, and 7. So therefore, our answer would be D, 7. Problem number 23. How many four-digit numbers have all of these three following properties? The tens and ones digit are both none. So in this case, I'll just write this right over here. 1, 2, 3, 4. Okay, so 9, 9. And the number is 1 less than a perfect square. The number is a product of exactly two prime numbers. So if it's 1 less than a perfect square, then we know that by perfect square, then if we add 1 to it, it'll be 0, 0. So by perfect square, so if it needs to end in two zeros, then that number must be ending in a 0 as well. What I mean by that is such as numbers 40. 40 square is equal to 3,600, which might work here. So now we got that. Now 40 squares ending in two zeros, and by that 40 is also ending in 1 0, so that could work. So 40, 50, 40, 50, 60, 70, 80, 90. And I'm going to write 100 as well. Even though it is a 5-digit, if we subtract 1 from it, it'll be a 4-digit number. And they're also saying that the number is 1 less than a perfect square. So then 100 can work as well. But now they also said that the number is a product of exactly two prime numbers. So suppose that we subtract 1 from 40, and we're going to get 39. Let me change the color. So we'll get 39. And if we add 1 to 40, we'll get 41. If we multiply these two numbers, we'll be getting 3,599. So but these two numbers have to be prime numbers, which they are not. So this cannot work. For 50, it has to be 49 and 51, which are not prime numbers once again. For 60, it has to be 59 and 61, which can work. So for 70, it has to be 69 and 71, which are not. For 80, has to be 79 and 81, which they're not prime numbers. For 90, has to be 89 and 91, which are not prime numbers. And for 100 has to be 99. 99 is obviously not a prime number, and 101. So this cannot work either. And so the only number that can actually work is this one right over here. Therefore, our answer is 1B. So problem number 24. In trapezoid ABCD, angles B and C measure 60 degrees, and AB equals DC. The side lengths are all positive integers, and the perimeter of ABCD is 30 units. How many non-congruent trapezoids satisfy all of these conditions? So, see this trapezoid right here. So I'm gonna make a line up here and split this somewhere like this, okay? And this one too, the same thing on this side. Okay, so something like this. So we know that this side would be 90 degrees and this side will also be 90 degrees. And we know that if this side is 90 degrees and this side is also 60 degrees, the same thing applies to this half over 2, then the top angle should be equal to 30 degrees. Since there's 180 degrees in a circle, so the top angle would be equal to 30 degrees. And this triangle is a special triangle. This angle is 90 degrees, 60 degrees, and 30 degrees. So the side lengths will also be special. So if this is x, then this would be 2x. And this would be x the square root times the square root of 3. Okay, but we don't really care about that for now. This one would also be the same thing over here. X, 2x, the same thing. But this one would be in y. These are just like random variables, okay? But it's in this kind of ratio too. So now we know that the area, or sorry, the perimeter of ABCD is 30 units, meaning that y plus 2x plus x plus plus y plus x plus 2x is equal to 30, okay? I just added all of these units up right over here, just these ones, and then I just put it over here. So now we got that. Now we can just try to combine these terms together. We'll be getting 2y plus 6x is equal to 30. Well, notice over here that this number is even, this one is also even, and this is also even. So the coefficients for these variables are even, and 30 is also even, meaning that we can divide by 2. So we'll be getting y plus 3x is equal to 15. Now, all we need to do is we need to substitute the values of x, and y. Suppose that x is equal to 1. If x is equal to 1, then we will get y is equal to 12. Right? So we got 12 because if x is equal to 1, let's just replace 1 over there, we'll get y plus 3 is equal to 15 minus 3 minus 3, y equals 12. So suppose that x is equal to maybe 2. Okay, so x is equal to 2, then y would be equal to 9. The same thing applies there. So, then we'll get x equals 3. If x is equal to 3, we will get y is equal to 6. If x is equal to 4, y is equal to 3. Because once again, the same thing applies here as well. Suppose that x is equal to 5. Then what happens? y is equal to 0. But can the side length be equal to 0? Well, first of all, they said that the side lengths have to be all positive integers. And 0 is neither positive nor negative. So 0 cannot be possible either. Suppose that we have a square here. Or maybe a rectangle, okay? Suppose that we have a rectangle over here, okay? We have a rectangle over here, and the side lengths are 1 and 5, okay? This one makes sense. But what if I said that this side length is 0 and this side length is 5? Would this make sense? No, because this side would not be existing at all if the side lengths would be 0. It has to be a length, a width, and yeah, for 2D. For 3D, it has to be length, width, and height. So this cannot work. The last scenario cannot work, meaning that there's only 4 possible ways that it can work, and our answer is E. So problem number 25. Michaela finds all possible ways to draw a 5x5 diamond-shaped grid, and each path starts at the bottom of the grid and ends at the top, always moving 1 unit northeast or northwest. She computes the area of the region between each path and the right side of the grid. 2 examples are shown in the figures below. One is the sum of these areas determined by all possible paths. So, see, this says a 5x5 grid over here, right? But why did they say specifically a 5x5 grid? What if instead of this they asked maybe a 95 by 95 grid? Would you really draw all of those squares? What if they said maybe 100,000 times 100,000? Would you really spend all of your time drawing those grids? Well, no. So what you would do then is that you would try to lower all of the possibilities, like you try to keep lowering down. So a 5x5 grid will be similar to 100,000 by 100,000 grid, meaning that a 2x2 grid would be similar to a 5x5 grid, right? They're like really similar. First of all, you need to understand the problem in a smaller way, and then you can try to extend all of those and try to connect it to the real problem. So we have a 2x2 grid over here, okay? So we have a 2x2 grid over here, and now they're asking us, even in the problem over there, they said that when they want us to find each path, okay? So to find each path, we would have to do, suppose that we can go from this, so right, up. Okay, so I'll just draw this over here. Up, right, up. And we can go from up, right. We can also go from right, up. We can also go from up, right. Sorry, let me draw this over here. Yeah. Another way would be maybe right, up, right, and our last possible way would be up, right, up. So these are the possible ways to do this. And the area of this one would be 0. The area of this would be 4. Okay? The area of this would be, see, if we place this one over here, let me just extend it. Let me just make this one bigger. Okay, so if we place this one over here, or something like this, okay? So something like this, then, okay, so something like this, then we will get that the area of this will be equal to 0, or sorry, the area of this will be equal to 1. This block right over here would be equal to 1. So let me just write 1 over here, or sorry. I'm gonna move this 1 over here, and I'll just write 1, okay? The area of this block. This one, on the other hand, will be equal to 3, right? This one will be equal to 3, like this sum. Okay, so that one will be equal to 3. This one would be equal to, here, let me extend this one, we would get 2, And the same thing would apply to this one over here as well. This one would also be giving us 2. And so you see that if we add all of if we add the sum of the pairs here, we would get 4. This would also equal 4, and this one would also equals 4. So the area, the sum of the paths over here will be giving us 12. So if the sum of the paths will be giving us 12, then another way to do this is that since let me list all of these down. So there's right, up. We do that over there. There can also be up, right. There could be right, up, right, up. There can also be up, right, up, right. There can also be right, up, right, and up, right. Sorry. Up, right, up. Okay, so there's these 6 possible paths, and now we have 4 letters, right? So if there's 4 letters, and we need to choose 2 ways to arrange, suppose that we have this, okay? We have R maybe here, and maybe R can be over here. And now we need to arrange these in as many ways as possible. So 2 R's and 2 U's. So we can do 4C2, which is the combination. So 4C2 means that 4 factorial divided by 2 factorial times 4 minus 2 factorial, just 2 factorial. So 4 factorial by 2 factorial times 2 factorial will be giving us 4 times 3 times 2 factorial by 2 factorial. So that will be once again giving us 6. Okay? So if we have 6 over here, then we will have to do 6 times. So we have 6 ways. And we have to do 6 divided by 12. I'm just going to write here because we don't have much space there. We have to do 6 divided by 2 to find the pairs. The number of pairs, we'll get 3 pairs. And remember that each of the pairs will be equal to the total area, meaning that it will be equal to 4. So 3 times 4 will be giving us 12. And once again, the total area will be equal to 12 here. That's also what we got up there. So we would need to connect this to the actual problem. And the actual problem, it's this one. So this problem, it says that we would have to draw a 5 by 5 diamond shape, okay? And in this one, we have to do the same thing. There's 10 ways, and there's 5 paths, or like 5 ways to arrange this. So 10C5 would be equal to 10, sorry, here. 10 times 9 times 8 times 7 times 6 times 5 factorial. And the bottom one would be equal to 5 factorial times 5 times 5 factorial, which is 5 times 4, times 3, times 2, and times 1. The 5 factorial and the 5 factorial will cancel out. The 3 times 2 times 1 and the 6 will cancel out. The 5 times 4 and the 8 times 10, they will both cancel out. And the top one will say 4, because 80 by 20 is 4. And we will be left with 4 times 9 times 7 divided by 2 to find the total pairs, divided by 2, which will be giving us, divided by 2, will be giving us 18 times 7. And 18 times 7 will be giving us, let's see, 126. And now we have to do 126 times 25, since the total area would be 5 times 5, which is 25. So 126 times 25 will be giving us 3,150. Therefore, our final answer is B. Does anyone have any questions?